The railway wagon is pulled out from underneath the rocket, and then the road transporter is pulled into position. The crane swings the rocket across and lowers it onto the road transporter. The road transporters carried the rockets to the field store of the technical troop. This was naturally selected for concealment and for its handiness to the firing sites. The railway engine shunts the wagons to bring the second rocket under the mobile crane, and the technical troop carried out the shifting process in the same way as before. In the German setup, there was one technical troop to 3 firing troops. Here you can see that the railway engine has brought the second rocket into position under the mobile crane, just as the first rocket leaves on a road transporter for the technical troops field store. When the rockets arrived at the field store, the technical troops' first job was to fix the warheads on the new rockets. The warheads were delivered in their cylindrical transit drums. First of all, the transit drum is lifted by a small crane. The rocket warhead weighs about a ton, and it contains about 1,700 pounds of explosive. The drum is supported at the front while the warhead is screwed onto the control compartment. When the warhead has been fixed to the rocket, a man removes the securing bolt which attached the warhead to its transit drum. Then the drum is slid off. Once the warheads were fixed on the rockets, the technical troop's next job was to carry out electrical tests, make minor repairs, and hand over a 100% rocket to the firing troop. They used the mobile crane a great deal in this work, particularly in the transferring of the rocket from the road transporter to the Meilerwagen. Each technical troop had only one mobile crane on its war establishment, so that after use of the railhead, the crane had to be towed to the rocket store and set up there. The mobile crane was not specially designed for rocket work. It was a standard piece of German equipment, capable of lifting 10 tons, which is considerably more than the weight of the rocket before it's fueled. The crane could be towed behind an ordinary vehicle. A well-trained team could erect or dismantle the crane in about half an hour. Besides the testing and the delivery of the rockets, the technical troop were responsible for the transfer of fuel from rail tankers to road tankers. This transfer was done by a small petrol-driven pump fitted to the side of the railway wagon. The liquid oxygen was always brought to the firing area by rail. The actual transfer of the fuel was delayed to the last possible moment to avoid losses by evaporation. The fueling troop's road tanker holds only 6.5 tons of liquid oxygen, enough for one rocket, while the rail tanker contains 30 tons. Not only that, but the road tanker loses 3% of its contents by evaporation every day. The long pipe is put on to act as an outlet. When firing was ordered, the firing troop sent their Meilerwagen to the technical troop's field store to collect a rocket. This meant that members of the technical troop had to transfer the rocket from the road transporter to the firing troop's Meilerwagen. The transfer of rockets from technical troop to the firing troop could be done anywhere. It was not limited to the field store. In fact, the rocket was often transferred some distance away so that the storage site remained concealed, especially from the air. Before the transfer took place, the rocket was completed. The warhead had been fitted, and the electrical tests were satisfactory. The rocket on its road transporter is towed under one side of the crane. The firing troop tows their Milerwagen under the other side of the crane. Then the rocket is lifted from the road transporter and transferred over to the Milerwagen. The Milerwagen supports the rocket in two places, with a clamp between the tank section and the tail unit of the rocket, and a clamp at the nose. The technical group lowers the rocket into the two clamps. The forward clamp, which grips the warhead, is tightened up by a ratchet. Then the main clamp is screwed up. The lifting tackle is removed from the rocket. Now the empty road transporter is towed away. The firing troop takes over the Milerwagen again. This elevator transporter is designed to have as much maneuverability as possible, and it can be towed at either end. The firing troop connects the Milerwagen to its towing vehicle and takes the rocket off to the launching site. Meanwhile, the rest of the technical troop are completing the fuel transfer. The pipes connecting the pump to each of the oxygen tankers soon become covered in frost and snow because the liquid oxygen is so cold. That white vapor is not, of course, oxygen vapor, but water vapor condensed by the liquid oxygen. When the road tanker is full, the inlet valve is screwed down. The men wear special gloves to protect their hands against the cold. Now the technical troop's work is finished. By this time, the firing troop were working on the launching site. Once it was prepared, the first step was to tow the launching table onto the site. The requirements of a launching site are extremely simple. You need enough room to maneuver your fueling and firing vehicles, and a hard base for the launching table. At Cuxhaven, we had no operational problems, so we were able to build a concrete surface. If you remember the actual German sites we showed you, you will realize that an improvised surface is just as effective as a specially prepared one. Now the firing troop screwed down the legs of the launching table in order that these legs could take the weight of the platform. This was done so that the towing dolly could be removed. The launching table is placed over a surveyed mark on the launching site. This is done so that the rocket can be accurately orientated later on. The towing dolly was pulled out and wheeled away. The launching table has an adjustable jack on each leg so that the platform can be leveled. There's a turntable on the top for turning the rocket when it's standing on the platform. The launching table is made of welded steel and weighs 3,600 pounds. Between the legs of the platform, there is a flame deflector which splits the jet. The firing troop brought the rocket to the launching site on their Milerwagen. They tow the rocket towards the launching table, but remove the towing vehicles while the Milerwagen is still about 30 feet away from the table. In order to carry out adjustments and tests when the rocket is in the vertical position, a cradle is put on the nose. This cradle is held in position until the rocket is erected by the front clamp of the Meilerwagen. The Germans move the Meilerwagen to the launching table by means of a winch. They can't use the towing vehicle to pull it, since the launching table is in the way, so they chose this winching method. The Meilerwagen is steered by hand into an exact position by the launching table. Once it is pulled right up to the table, the supporting jacks on the Meilerwagen are screwed down. Now the Meilerwagen is able to erect the rocket on the launching table. Although fueling would be easier with the rocket in the horizontal position, this wasn't done because of the light construction of the fuel tanks. These tanks are designed to stand the weight of the fuel only when the rocket is in the vertical position. In the horizontal position, the tanks would collapse. When the rocket is empty, it weighs 4 tons, including the warhead. But when it has been fueled, it weighs about 12.5 tons. The Meilerwagen arm is elevated by 2 hydraulic rams. The pressure for operating these rams is supplied by a small gasoline engine. This man is in control of the operation. The elevating arm of the Meilerwagen holds the rocket an inch or 2 above the launching table. Then the legs of the launching table are screwed up so that the table can take the weight of the rocket. The clamps on the Meilerwagen are released so that the rocket is standing without support on the launching table. The elevating arm of the Meilerwagen is lowered about 10 degrees. Then the jacks supporting the Meilerwagen are removed. This enables the Meilerwagen to be manhandled 90 centimeters, or about a yard, away from the launching table. Then the testing platforms can be fitted to the Meilerwagen at various heights. Meanwhile, the fueling troop were bringing up their fuel train. The train consisted of a towed alcohol bowser, a self-propelled alcohol bowser towing a trailer pump, then the towed liquid oxygen vehicle, and finally the bowser for T-Stoff, or hydrogen peroxide. The fueling vehicles were concealed near the launching site until needed. At the launching site, the survey party now leveled the rocket. This was an initial leveling process to be checked at a later stage. The leveling was done by adjusting the legs of the launching table. The technicians of the firing troop removed the jet covers from the venturi. They also bolt the carbon vanes into position. These vanes were not put on earlier because they are easily broken. The air-operated valves in the fuel supply system are tested by using a mobile air compressor. This compressor is also used to fill compressed air bottles in the rocket. Paper covers, rather like paper drinking cups, are put over the oxygen jets. This is to make sure that the oxygen does not cause mechanical damage to the jets. When the preliminary tests were completed, the alcohol vehicles were called from their temporary parking place. Alcohol was always the first fuel to be filled in the rocket. The rocket is fired electrically from a control panel in a special vehicle. The electrical cables connecting the control panel to the rocket are supported on a long pole attached to the launching table. During the tests on the rocket, the batteries become exhausted, so they have to be replaced. When the alcohol fueling vehicles arrived, they parked along